So in previous video you have learned about the context-free grammar and what is its purpose. You will be, there is no right hand side, it can have any terminals or non-terminals. No specific order is there like regular grammar. It will be ending with a single non-terminal. No such restriction is there in this context-free grammar. Those things you have learned. So purpose of context-free grammar will be like it helps in deriving some strings that forms a language with the help of the variables as well as the non-terminals. Okay, so in this video you will be learning about some new concepts like derivation trees. Derivation you have learned earlier to derive any string. Within that itself you will be coming across leftmost derivation and rightmost derivation. Then one more thing, that is ambiguity in context-free grammar. So we can consider the old example itself, that is S gives ASA, S gives BSB and S gives epsilon. So if you are asked to derive some string W is equal to AB, AB, A. Okay, in order to derive the string AB, A, ABA like this, if you are asked to derive, means first which production you will be taking from this given set of productions, you will start with the first one, that is in order to derive the first input symbol from the string, that is A. So S gives AS, A you will start with that, and one non-terminal that you have to replace is S. So from this set of productions you have to choose. So here the string is having the second input symbol as B. So from the production BSB can be taken. So AS, BSBA by applying the second rule. Okay. So you can write that rule within the bracket. S gives B, SB like that. Then A. Then the third input symbol will be A here. So you have to take again the first production. So A, S, A, B, A. Then lastly, third input symbol is A. So you have to make this epsilon as S as epsilon, so that the required string will be obtained from the grammar. So take the third production. So you will get ABA, ABA. So here you have applied S gives epsilon. In this step you have applied S gives AS. Okay. So this much thing you are aware of it in previous class itself. Okay, substituting the right hand side you will be getting the required string. Now what you are going to learn new from here is you have to generate a tree from the derivation. So this is the derivation. The process is called as the derivation. From the start symbol you have derived some set of terminals which is forming a string. That process will be called as a derivation, and if this string is obtained and is visualized in a pictorial way in the form of a tree, then that will be called as a derivation tree. So we can see how it can be drawn in a tree. You can start with the start symbol itself, similar to the derivation from where we have started with the start symbol. Here also we will start with the start symbol S. What is the first production we have used? S gives ASA. So you can draw like this. A, S, A. So S is the root which is starting with the non-terminal. Okay. Now next S, again a non-terminal, here S is there. Second production what we have used over here, S gives BSB. So you can write over here B, S, B. And again this S need to be removed. So third production what you have used for S, ASA, A, S, A. And finally you used epsilon. Okay, so this shows the tree where the leaf denotes the string, and the subnodes, it will be taken as the nodes. Okay, the leaf nodes will be taken as a string, and the subnodes will be taken as nodes will be taken as the non-terminal. Okay, so this is called as a derivation tree. And so derivation tree in a context-free grammar will be represented using what? The trees. And the trees, that is the nodes can be decided based on the derivations. Based on this derivation only, you have selected this nodes S like this. Okay. So we can see another one example. Here only a single non-terminal is used in this example. We can see one more example. So you can take an example like S gives AAS ASS, and A gives SBA BA. Now derive the string from this set of productions. You have to derive the string W is equal to AA B AA. So how you will be able to derive from this set of strings? Okay, so this I will solve it for you. So from this grammar, from this set of productions, you need to choose S is having three set of productions. Two set is starting with A, and one is starting with a non-terminal itself, SS. Okay. So here it seems to be like in between A is not there. In between A it has B is not there. Only a single B is appeared over here. Before that, two A's are there. So B term will be there for this non-terminal A. B terminal, it has appeared in non-terminal A. S is fully dedicated for this terminal A. So for time being, we can choose this production S gives SS. If you choose AAS and or this one, what happens? You won't be able to derive the string. You can just try and see if you start with this S gives AAS, A has to be replaced with the right hand side of the non-terminal, the second production, which will be starting with, there it has some B like that it is having, and this terminal BA is also there. So there is less chance of getting this particular string AA B AA. So from this grammar, I am just choosing the third production of S, that is S gives SS. Okay, this I am choosing. And now in order to derive the first symbol A, this S will be replaced with the single terminal symbol, that is the right hand side of the production. So here this S, we can to replace this S, you can select the terminal symbol as from the set of production. You can take this A. So here one more thing that you need to see is there are two non-terminals in the right hand side, isn't it? Two non-terminals are there in the right hand side, and if I am choosing the leftmost non-terminal for the derivation, means throughout the derivation, throughout the process of derivation, you need to choose only the leftmost non-terminal. And that type of derivation will be called as leftmost derivation. Okay, and it will be denoted as in above this derivation symbol, you have to write LM to indicate that throughout this derivation process, you have taken only the leftmost non-terminal. Okay, so if the during the derivation process, if the leftmost non-terminal is replaced with the right hand side of the production, then that derivation will be called as what? The leftmost derivation. Similar is the case with the rightmost derivation. If the rightmost non-terminal is taken for replacing it with the right hand side of the production, then that derivation, the particular derivation will be considered to be as the rightmost derivation, and which will be represented like instead of LM, it will be taken as RM. And RM should be specified above that derived symbol. Hoping that you are able to understand. So for time being, I am using here the leftmost derivation, and so the leftmost non-terminal, here two non-terminals of the same name is there, same S is there. So take the leftmost S and replace it with the right hand side of the production. So here I am using the second production. I am replacing it with AS. So which production I have used? S gives A. Okay. Now again you have to take the leftmost non-terminal. Here only a single non-terminal is there, that is S. I have to replace this S with any one of the right hand side of the production. So here one of the right hand side, you can take it as that if I take this A means what happens there, it will derive a string as AA. Okay, so in order to derive some other set of string, some set of variables need to be derived from the grammar to generate the string. What you are going to choose? You are going to choose a different production. So instead of A over here, I am choosing the first production, that is AAS. Okay, so here now you got two A's over here, isn't it? Two A's, it is there. Now third terminal, so you can, here you have applied S gives AAS. Again, third symbol is B. So in order to get the B symbol, what you have to expand? The non-terminal A. So which non-terminal you can choose to expand that? You can try with the first one. So if you try with the first one, you won't be able to generate the remaining BAA. Okay, so you can just try with the second, BAS. S gives BA. Okay, now one more. Now the first four symbols, it got matched over here, and finally which one you have to use? AA, BA, A. Second production of the S. S gives A. Okay, so now you got the string AA, BA. Now in order to write the derivation tree, or what you have to do, you have to start with S. Start symbol will be the root node S. Then which production you have taken? SS. So based on the derivation only you will be writing this derivation tree. SS. Then which leftmost left node is there, right node is there, isn't it? So based on the derivation, left node is replaced with S gives A. So here A, And again um, next this s will be replaced with which one? AAS. A A S. Again A will be replaced with next production. S gives BA. And again S will be taken as A. Okay, so now you can see that the leaf nodes will be forming the string, and this will be the derivation tree, and the derivation that we have taken is the leftmost derivation. So what is the difference with the rightmost derivation? Only the way in expanding the non-terminal only it is different. Way in expanding the non-terminal, which means that we can see with this example itself. That is, if we have started with, if I am taking Rm, okay, I am starting with SS. So which non-terminal will be expanded here? Right hand side two non-terminals are there. So for rightmost derivation you have to expand the rightmost non-terminal with the with the required production set. So here rightmost non-terminal, if I expand, means which will be the production I have to expand? Just expand it with A. We can see so it will be like S A. So here you have to match it with the right hand side of the string. So the string that we need to derive is A B A. So S gives A, you have expanded the rightmost non-terminal. Now the rightmost non-terminal is this one. Again you have to expand it with here you can check this leftmost derivation. You can check SA, what you have used? S gives BA. So you can take S gives BA. Sorry, it gives BA. If you take, means what happens? It will be generating the string as such, and this is not the string that you have to generate. So you have to choose the other set of productions. Which production you can choose? S gives SS, shall we choose? Sorry, S gives AS, we can choose. S gives AAS A. S gives AAS. Now again I think we made a mistake here. S gives AAS. Okay, I think I made a mistake over here. 1 second. I think you won't be able to derive the string properly. So rightmost non-terminal, we can replace it with the AS. Okay. AAS. S gives AAS. And again, this S can be replaced with A. So S gives A, S gives A. Again, this A can be replaced with BA. S A B A A. So A is replaced with what? BA. And finally, this S, the leftmost S, can be replaced with A. So which will result in what? A, B, A. Okay. So repeatedly when you do only, you will be able to understand how you are how you will be able to choose a production in order to derive this string. Okay, so this is a case with the leftmost derivation and rightmost derivation. And we can see that the leftmost derivation and rightmost derivation, the order of applying the productions is different. Here first you have applied S gives AS, and in leftmost derivation you have applied S gives A. The order in applying the production to the right hand side, it is different. But the derivation tree finally when you draw and see means it will be same only. Okay, so that is the common thing for leftmost derivation and rightmost derivation. The derivation tree will be the same. And we are coming to the last thing that we are going to see is ambiguity in the context-free grammar. Okay, so what it means is, if the now we have seen this AABA derived using the leftmost derivation and rightmost derivation, isn't it? And the derivation tree is a single derivation tree. Ambiguity in context-free grammar, it means that if there exist more than one derivations, okay, if there exists more than one leftmost derivation or more than one rightmost derivation, then we can say that the grammar is ambiguous. That we can see with the help of an example. Here in this example we can't say that the grammar is ambiguous, because the string can be that is this AABAA, this string can be derived using this combination alone. There exists only a single derivation tree. Okay, there exists only a single derivation tree, and leftmost derivation also there is only one, rightmost derivation also there is only one rightmost derivation. So this grammar, it is a non-ambiguous grammar. Okay, so a grammar is said to be ambiguous if there exists more than one leftmost derivations, more than one rightmost derivations, or more than one derivation trees. Okay, if there exists more than one leftmost derivation or more than one rightmost derivation, or it is having more than one derivation tree, then we can say that the grammar is ambiguous. So that we can see with the help of an example. So consider a grammar. S gives S plus S, S gives S star S, and S gives A, S gives B. So you are asked to see whether the grammar is ambiguous or not. So for time being, derive some string using this grammar. So for example, you can take a string like W is equal to A plus A star B. Okay, and we can see with the leftmost derivation. So how you can write the leftmost derivation? You can take some symbol, you can take like S derives LM, S plus S. If you are starting with S plus S, leftmost derivation, leftmost non-terminal S will be taken. So what you can do, plus so here that you can see that already plus is there, so you need to get a symbol A. So A plus again S, applying S gives A. Next what you have to do, A plus, leftmost non-terminal is S, so A plus you need to derive the term for star, so choose this production S star S, S gives S star S and A plus. Now you got both plus and star, and replacing this S with A, you will be getting the string A plus A star A. Okay, this is a form of leftmost derivation. Same way, you will be able to get the string applying different forms of production. Applying the productions in a different way, you will be able to apply the you will be able to derive the same string. We can see that is, you can start with, instead of starting with S plus S, you will be able to start with S star S also. Okay, and leftmost non-terminal, if you are replacing means you can S plus S star S. For here S gives S, S plus S, then S gives A, S plus S star S, leftmost non-terminal A plus A star S, A plus A star S, sorry, A plus A star A. Okay, so here you can see that there exists more than one leftmost derivation for this string A plus A star A. By applying the productions in the different order, you got more than one leftmost derivation. So when you plot or when you draw the derivation tree also, you can see that the derivation tree obtained also will be different. So if you write the rightmost derivation also, you can see that it is having more than one rightmost derivation also. So we can say that the grammar is ambiguous. Okay, so if there exists any one, more than one leftmost derivation, more than one past tree, or more than one rightmost derivation, we can say that it is an ambiguous grammar. Okay, but these three things, any one thing got satisfied means you can say that the grammar is ambiguous. You can just check with the past tree also. That is a derivation tree. Starting with the non-terminal S. S plus S A S plus S star S A A. Okay, here you got this. String. Similarly, we will be when you draw this tree for this derivation, you will be getting some other parse tree where it will be starting with STRS. So hence the grammar will be called as what? The ambiguous grammar. So check and see whether you are getting more than one rightmost derivation also for the same grammar. Okay, so for this problem you just draw the write the leftmost derivation, two leftmost derivation, two rightmost derivation, and as well as the derivation tree also you have to draw. Okay, so complete till this, and we can see in next video.